Hey there, welcome back to Farmcraft. I'm John. This is a 1960 John Deere 1010. If this is your first video on this machine, you're really going to want to watch the previous videos. I've made a playlist of it. So in this video, I'm doing all the other things that we need to get this machine so that I can drive it around, do a break-in, and see if we can make it stop smoking. Whether I'm successful or not remains to be seen, but I can tell you
that long for it to quit smoking. But I do need to operate this thing for quite a while. And I have another leak. This is coming from, and it looked at first like the oil pan, but it's not. It's coming from here, but it's dripping down underneath that, coming from the hydraulic pump. There's a gasket in here, but I don't think that's the problem. There's a seal. Of course it's a seal. There's a seal in there, the shaft that comes in and drives the pump. So I'm gonna have to deal with that. Right in the center there. Leaky seal. So it was leaking into here, running down that, and then coming out there. Didn't leave me a whole lot of bite to work with. Yeah, that one came loose. Got that one.
Leaving the screws you've gotten loose in place can help you get the other ones out. So I screw this one back in. And you'll see I put the first one I took out back in just a second.
Wanting to strip. Oh, man. The other thing is an impact. Look at that. Impacts are something else. Oop. And sometimes they do that. Man. Well, darn it. She wants to fight. Yeah, that's what I thought. No, I'm not rebuilding the gear pump.
Look at this damn seal. Right. Let's see what happens here. No chance. That's my prediction. Yeah, I don't even think I can grab it. It's coming out. Wow. Okay, I'll take it. This is a carbide scraper I use for prepping gasket surfaces. It leaves some marks that make it look like it's gouging it up, but it's not. It's very smooth. Yeah, I'm using the same O-ring because no one had one, and this one really doesn't look bad. I think it'll seal just fine. Scrape those faces, though, to make sure there was nothing sticking out that would prevent, because the O-ring has to press right against that lip there. Now, wouldn't you believe it, I checked 2 auto parts stores and the John Deere dealer, and nobody had this screw. Shouldn't have even bothered. I should have just made one. Actually, before I go making one, let me see if I can find one. This is a thread checker. So yeah, it's a 1024 thread. Yeah, it's not right. Nope. Those look like electrical. Those are going to be a finer thread. Actually, I think they're smaller. Yeah. What is that? That looks close. That's a 1024 thread. Look at that. It's even got the countersunk screw head. It's a Phillips, but whatever. Doesn't matter. So all I need to do is shorten that. So the other 3 really aren't bad. I think I might just touch them up a little bit with a Dremel. As long as that goes okay, I'll use those again. Yep, that's gonna work. I have a little cutoff wheel for my Dremel that I would use to do that slot. Can't find it, but I have this. This is a little diamond wheel and a drill. It's pretty janky, but it's working. $7 for a new seal, which is great, but it took 2 days to get it. Sometimes I forget about that thing. Okay, I've got my new glow plugs, but before I burn them up again, I want to check something. Wiring diagrams. Not my favorite thing, but it's really not too bad. Basically, on this machine, there is a voltage regulator right there, and the key switch right there. The glow plugs are powered right here, this GL, if you guys can see that. GL goes down here to the glow plugs. They are either powered through B2 or B1 on the key switch. I'm not sure which. I'm going to test that in a second. B2 is the regulated voltage coming out of the voltage regulator. B1 is unregulated voltage coming out of B, which hooks directly to the battery through the starter. So main battery cable goes over to the starter and then comes up to B on this voltage regulator, and it's just spliced together there, goes directly to B1. Now, you'll notice on this machine that the positive is hooked to ground and the negative is run to the battery. Everything's opposite because the starter solenoid has to have the positive for it to work.
and just the way it's wired. But these are glow plugs. It's just a resistive heater. It doesn't care which way the current's coming. So it's backwards, and all I want to work on this machine is the glow plugs and the start. So I'm going to test the key switch and see if it works. If it will send power to the starter and send power to the glow plugs, I'm going to disconnect everything else so I don't have to worry about any shorts or anything like that. And we'll just run it that way. So that's my plan. Electrical stuff is hard to film. I'll try to make it interesting if I can. So here's our key switch, and it's got it labeled B1 and B2. Check that out. A kind viewer sent me an actual meter. I've been wanting to buy one of these for years. Thank you very much. So from B1 to the glow plugs should be no continuity right now because I don't have that switch on. So if I put the key in and rotate it left, that's turning on the glow plugs. So let's see if... Oh! Did you see that? I had a little bit there. 33 ohms. No ohms. So it looks to me like this is supposed to be... Yeah, it's definitely coming from B1. Let me double check myself here. B1 is direct to battery. So that tells me that this should be unregulated voltage. Well, that's a good thing. That means I ought to be able to hook this straight to 12 volts. Obviously, I'm getting 32 ohms, so I'm not getting a good connection in here. I am going to pop this thing open, if I can, and see what's going on inside it. Why not? Well, it's a wonder that isn't working. Basically, you're making connections here, which I can determine what's what looking at the back. So the glow plugs are right there. One of our electrodes is burnt up, but the good news is I only want two things to work, and that is start and glow plugs. So I can make these two do what I want. I don't need this one. This little cutout here goes on this tab, and this has two tabs that correspond to this and this. So it only goes together one way, so I'll look at it for a little while and figure out which connections I need to make. Glow plugs are when you turn left that way, which would be that way. And there's the locating tab right there. And here's the back plate. It would go just like that tab and that tab. And here's the glow plug wire, and right beside it is B1, which is the unregulated straight to the battery. That means I need a connection between those two, and it turns out, I'm hoping you guys can kind of follow what's going on here. Those two need to connect. It would be with this one. So right now, this is here. I'll leave my finger there. You can see it's not. So when I turn the key, this comes down and makes a connection between those two. And then it's spring-loaded so it goes back. Yeah, when I go right, I'm going to make a connection between these two. And then in the start position, it'll be these two. And that is S, yeah. It's those two. This last one is not even used. So we need our spring. Our plate with our cleaned electrodes. Should have no continuity between B1 and glow plugs. If I turn left, I should. Nothing. That's a bummer. Well, getting a good connection now. Maybe I need a stronger spring in this thing.
Alright, I found this in my little spring drawer. Yeah, it's definitely got a little more pressure, not too much. And I'm also going to put some dielectric grease on everything. And this thing keeps falling off, so I'm going to put some grease on this just to hold it. Hopefully make that kind of stick and stay put. Yeah, like that. Okay, heavier spring. Well, that worked. Well, that works surprisingly well. Now, do I have connections? So this is the glow plug. Look at that. No ohms. That's what we want. And this would be the start. From here to here. Start still not working. Oh, that's interesting. If I crank the key all the way, yeah, if I just don't go all the way with the start, it's got a good connection. Yeah, I can do that. Okay, key switch works. Well guys, I got a new dozer, and this one was only 800 bucks. But the controls are a lot different than any dozer I've ever had before. It's gonna take a while to learn. 800 bucks though, what kind of deal is that? I'll tell you what else, it's brand new. Brand new dozer. Come here, Dozer. Come here, buddy. This is Dozer. He's an Anatolian Shepherd, and he is 3 months old. These are livestock guardian dogs, and he's going to get to around 130 pounds. He's like 30 right now. And they're big dogs, but they live a long time, so really good dogs too. Say hi, Dozer. Yeah, haven't figured out the controls just yet. So looking at this voltage regulator, this thing may work, but I don't need it. I need power to the key switch. I actually already have off of the battery post, I have a tap. So I'm gonna run power to both, straight from the battery to the key switch, to both B1 and B2. And that's gonna supply power for starting, and it's also going to supply power to the glow plugs. So I'm going to run a heavy gauge wire from that to here, and everything else is going to be disconnected. So all that other rat's nest of wires in there, these things flopping all over the place, none of it's going to be hooked up, and don't have to worry about shorting something out. Yeah, that green is for glow plugs, right? That's the right color wire. Yeah, pay no attention to the color of that wire. It's what I had that's large enough gauge. All right, we're over on the other side where the key switch is going to be. That'll do it. Okay. Now I need the high current carrying for the glow plugs, not so much for the starter solenoid. So what I'm going to do is we're going to put this there, and then I need to jump to the other side. So I've got this little jumper wire that's going to carry the power over to B2, which can then supply power to the starter solenoid, if that makes any sense. These are the two wires that I need to hook up. This is the glow plug wire, and now I just need the starter wire. Here I'm putting the new glow plugs in.
We're actually just looking at the ends. See how it's all swelled up there? That's fried. So yeah, Area Diesel got these new plugs to me again, got them to me fast. Kurt over there has been helping me. We've been sort of both researching to make sure that 12 volts is okay for these. They've just been so helpful. If you are working on a diesel engine and you need some help, give them a call. They'll probably be able to help you. I am a little gun shy about burning out these new glow plugs. So I have that meter, which can record DC amps, set over the glow plug wire. Based on the resistance that I measured in the wire, I am expecting an initial current around 60 amps, should rapidly decrease to 30 amps. 30 amps would equate to 7.5 amps each. That's within spec. So hopefully that's what we're gonna see. I'm gonna reach up here and hit that glow plug key and hope we don't burn out our plugs, but I don't know what else to do. Here we go. It might help if I hooked up the battery. Be right back. All right, take two, literally. Here we go. 60, that seems like a lot. What do I do with that?
I really don't want to burn up another set of plugs.
All right, so I've been talking to my patrons who have been really helpful. A lot of those folks over there are really knowledgeable, and electrical troubleshooting isn't my forte. So I want to put an inline resistor between the battery and these glow plugs so that I don't blow them up. I say blow them up, burn them out. There's a very good chance that as the plugs get hot, the resistance is going to increase, the voltage would drop, and maybe they're fine, but I've already trashed 4 of them, and these things aren't cheap. So I'm trying to avoid that. So after some rounding around and some brainstorming with my patrons, thanks guys, you guys are awesome. And we've got some patron exclusive content over there. If you want to go over there and check it out, you can see the process we went through to get here. But I ended up using some heating element wire to make my own resistor. This should limit the current to a maximum of 30 amps, probably less. So the plugs won't heat up as fast, but they will heat up. That's plenty of amperage. And then I should be able to see, is the resistance going to drop over time or not? So what I have here is battery voltage. We're going to see how much battery voltage drop I get, and then DC amps going to the glow plugs. So I would like to see that start out around 30 and then decrease to something like half of that. And that would tell me that the plugs probably can handle straight battery voltage, although I'm not really sure. Now, this stuff I had to solder because it's brittle. You can't like twist it up and connect it that way. So, and of course it's a heating element, so it's a possibility that solder is going to melt. But I think it's going to work long enough to give us the answers that we want. Volts, amps, and I'm going to reach over and hit the glow plug. This will probably start glowing red, and let's see what happens. So, contact. So 31 amps, getting a little smoke here. 12.5 volts, not a lot of drop. 30 amps. Yeah, that's sagging. This is such a janky setup. So we're settling at like 22. So it came down some.
So that was about a 25% drop in amperage. If you do the math, starting at 65 amps, that would end up with each plug taking around 12 amps. Well, I took these on my belt grinder and I ground them flat. So we're looking at one of the old plugs. You know, the connections here, it's insulated down through the coil, and then it connects to the case, which is connected to the block. And that's how you connect the circuit. The new one is here, and you can see that the wire size is smaller, which kind of confuses me. Why would the ohms be less? I'm not sure, unless there's already an internal short in it, and maybe that's the problem. You can see it bulged out here, so got too hot. Yeah, but it pretty much looks like similar build, just a smaller wire on the coil. The inline resistor here protected them from self-destructing.
Just for troubleshooting at first, I may continue to use this because that worked. Long term, it might be a matter of turn the plugs on for 10 seconds, turn them off for 30,
turn them on for 10, turn them off for 30, and just let them get hot and then let the heat sink into the block and then get hot and sink into the block just to keep from burning them out. I have a feeling if you just put them straight to battery and put them on for a minute or two like you're supposed to do, I think those plugs would end up smoking again.
But the good news is we now have glow plugs again, so we can try to start this thing again.
Okay, so here we go. I'm going to check the amperage on the glow plugs. We're going to do about a minute, and I'm also going to give it 2 pumps on the primer pump. So this is what it calls for in the service manual. So 1, 2. So we are primed. Now we are going to glow plug. 30 amps. Got it at half throttle. Plugs are warm. Let's crank it. Smoky, but nothing like it used to be. And that's the first time I started it without starting fluid. And it actually started pretty well. Not leaking.
People were wondering why smoke was coming out of the radiator like you can see here. The muffler is just sitting on there loosely, so a little bit of exhaust leaks out underneath it, and it just gets sucked in by the fan and blown out the radiator. Alright, so I want to try to tweak the timing by twisting the injection pump and see if that helps the smoking. I had been planning on doing this, but I must say, many people in the comments were quite confident that this is what I needed to do, and well, let's see what happens.
That is what I wanted to see. That is running great.
So here's before adjusting that pump, and here's after. All you folks that commented it was the timing, you were right on the money.
Yes!
It still wouldn't shut down though.
So I just looked, made sure it was at top dead center and checked the timing mark in the pump. And they are very close, but not exactly on. Me twisting the pump to the right, which made it run better, made it further away from the timing mark. So, you know, I think that's the deal. The timing mark gets you close, but the reason they give you an adjustment on the pump is so that you can fine tune it. And it's much happier there. I just got off the phone with Kurt at Area Diesel because I wanted to know what he thought about the timing mark being off. And what he is thinking, this pump has adjustments here that affect the timing advance, and it changes based on the RPM of the engine. And I never messed with those. I left them how they were, but that doesn't mean they were right. So if those aren't right, then the timing mark may not necessarily be right. So twisting the pump would be necessary to make it right, if that makes any sense. That's probably what's going on. which really highlights the value of sending a pump like this to the experts to have them do it. I'm seeing more and more trying to do this yourself. I mean, you can do it, but man, it's so nice to have it done right, have it calibrated, and know everything in the pump is functioning as it should, because now there's still all these question marks. The other thing is, why won't it turn off? They actually reviewed my video, and the pump rebuild expert over there saw that I had left a clip out on the throttle shaft. It's right behind here. Yeah, I think I'm going to end up pulling this pump, fixing that clip, and I also want to change the vanes on the vane pump. So I'm going to do that once I get all the parts, but he thinks that's why it's not shutting off, is because that clip is not there. Basically, the clip ties the shut-off function to the throttle shaft, and right now they're not tied together. So even when I move this all the way down, it doesn't turn the engine off because it's not actually doing what it needs to do inside in order to do that. If that makes any sense. We'll get to that later.
All right, we can fill up the cooling system with antifreeze, so I don't have to keep worrying about this freezing overnight. Here is the dipstick for the reverser, which, if you recall, was not on the stick. It's below that, and I can see why, because we had to replace that seal. Darn seals. Let's top that off. Right at the full mark. I don't know if you guys can see that or not, but I don't really care. It's at the full mark. I'm just kidding, I care. Of course I care. Actually, it's very annoying when you try to film something and then go to edit and find out that they couldn't see, because trying to make good videos here. See how the engine oil looks. It's a little bit above full. Not much. Close enough. I don't think this old pig is gonna mind. Hydraulic oil. So I thought this was a paper pleated filter, but this is a metal filter. And a lot of old systems were this way. You just clean this thing out. I called the dealer. They said this is obsolete. You can't buy a new one. And yeah.
This is looking down into the tank.
You are living up to your name, Dora. All right, let's get some oil on this thing. I can see the dipstick. Well, apparently 5 gallons isn't enough. Brake cleaner. And I bet some of you are worried about little fibers of cloth and maybe a chip of paint or something getting in there. And of course, I'm trying to keep all that out. But the reality is that stuff is not hard. What you don't want to happen is something that's like sand or a chip of metal to get in there that can potentially scratch the pump gears or scratch a hydraulic cylinder. A little fiber of this, a little piece of cotton, or a little piece of silicone is just going to get annihilated in that system. It's not going to scratch anything. You don't want it in there, but it's not the end of the world. All right, using some RTV. Why red? Because it's what I got. You got to run what you brung. There it is.
Yes, I should have put RTV on the threads of these bolts as well. I do not want water getting in this tank. I went back and did that off camera later.
All right, I'm gonna let that sit like that for an hour and then I'll crank those down.
1 hour later.
All right, it's quitting time. See you tomorrow. Dora's living up to her name. Okay, well, it has been raining for 2 days and everything is sopping wet out there. And that's what I want to do, is go up and drive up and down that hill and load it up that way. But it's going to be a real mess today. So that's one thing stopping me from doing it. The other thing is I need to do some work on this pump. I need to put a clip in there so that it'll shut off correctly. And they made a new style of vane that I'm going to put in there that apparently lasts longer. This right here is leaking diesel fuel, so I'm going to have to put some thread sealant or Teflon tape or something on there. And this petcock leaks. So so what I'm getting at is I'd really like to go drive this thing around, but rather than doing that, I think I'm going to fix all these little things and get it so that that we're really done when it comes time to drive it around, or at least at least closer to done. Oh, and did I mention that this thing started leaking again? Putting the coolant in it made it leak. What the heck? Pandora, let's go. All right, I am gonna scribe where this pump is. While I'm working on the pump, I'm draining the coolant out of the block so that I can fix this. And you know what? You have to drain the coolant in order to pull the valve cover. I might as well pull the valve cover and retorque the head bolts. I've come this far. Damn it, Dora. All right, so it's right behind here that I need to put that clip to get this thing to turn off when I tell it to turn off. Betting you this thing's going to dump some fuel here. See the problem? Yeah, it's obvious. And I'm pretty sure it's just a matter of yeah, see, so that's giving it throttle. And now when I pull down, this is the metering valve here. That little clip now pushes on that metering valve and pushes it all the way closed. And I didn't have that clip on there, so the metering valve was just basically in idle position. In idle position instead of closed position. So basically all I needed was this here to go to there. I think the other thing that does is it really locks this in, if I'm not mistaken. Yeah, that won't come out now with that clip there. So I was wondering about that when I put it back together, about this, because this just kind of snapped in. I didn't realize I needed something to actuate that metering valve. So there you go. It should turn off now. I'm using the yellow Teflon tape with these. Obviously this hose clamp is not working, and this is a new line, but that hose clamp beat it up pretty good. Yeah, I'll go ahead and cut a new piece. Alright, I've got this style of hose clamp, which does a lot better. Now the vane pump. Behind here is the vane pump, which is kind of like the transfer pump or the lift pump. It's not the high pressure pump, but it pulls from the tank into this pump. And there are vanes, and this is the new style vane that I did not put in when I did the rebuild. And I think it's Corey over at Area Diesel saw the video and said, you really ought to put those in. It's going to last a lot longer. So
So I'm going to do it because I know those guys, well, especially Corey, knows what he's talking about. Which means I get to do this lock wire again. For the record, I don't have any actual lock wire, and this is music wire that I used. It's not the easiest thing to work with. You see, the old vanes are metal with a spring. And the new vanes are some kind of composite. And that's all I had to do there. Only 25 inch-pounds on those. That's why the lock wire is necessary. I'm not going to make you watch me fiddle and fumble getting that back on there, but, well, let's just... The way I had it mounted before, I couldn't twist it right quite as far as I wanted to. Yeah, it looks like it was right there. So I'm going to twist it a little more right. Yeah, just a little bit. And that should put me at a place where I can twist it back left if I did have it in the optimal spot. But I want to see if a little further right doesn't make it even better. You might recall I pulled this thing off when I was trying to get this thing to start so that I could see the cylinders and get some kind of idea of the condition of the engine. And it didn't even allow me to see the cylinders well. And now it leaks. So that's annoying when you do something that just makes it worse. But if you work on stuff, that is going to happen. So that's the pre-combustion chamber, or this half of it. And coolant is leaking out here. All right, so this is what I'm thinking. This right here is actually, I guess that's rubber. I guess that's an O-ring. Yeah, look at that. Thought it was some kind of carbon thing, but it's flexible. And that's where it's supposed to seal out the coolant from leaking out, and it's not doing that. So that's junk. Let's go ahead and get it out of there. When I bought my seal kit, it came with a whole slew of things, none of it labeled, so you don't really know what it is. But it came with these orange O-rings, which a lot of times orange are for coolant, and that looks like the perfect size, actually, to go right there. So, and that seals against this face, which this face feels pretty good, so that should do it. So I'm going to put some grease on this thing and see if we can't get this back down in there. See if it doesn't feel like it pops in place, because if it does, I think we're good. Oh yeah, it went in there nice. Never ends with this thing.
And of course the gasket had to stick on both sides.
So it's a metal gasket. I'm going to put some Permatex on it. But a commenter made a very good comment, and I wish I had known before I put this on the first time. It's a brand new gasket. Who makes a gasket like that? It's a valve cover. You're going to be taking it on and off. Anyway, he said to put Permatex on one side, grease on the other. That way it'll stick to one side only and come off without tearing. Like that.
Some of the bolts did move a little bit, so I'm glad I did this.
Okay, so now the valve cover gasket, I am going to Permatex it down and then grease the edge of the valve cover to try to get it permanently there, and then hopefully it's not going to leak. If it does, I'm going to have to get another gasket. Never ends. Damn it, Dora! Oh! I didn't hit record, but I just did Permatex all around that perimeter there.
And rather than greasing the underside of that heavy valve cover, I decided to just brush grease onto the top of the gasket. I adjusted the valves again, put the valve cover back on, and torqued it down.
Okay, valve cover's back on. You know, with that sealant in the grease, you can see a little bit of gook around the valve cover. I haven't run it yet, so obviously that's not a leak. I'll just leave it like that. I ought to be able to tell if it leaks. Oh, good grief. Go ahead and put our coolant back in. Well, no leak yet. So it's been together for a while, and it was dripping like, you know, every 30 seconds I'd get a drip. It isn't leaking. So this petcock valve on the tank, there's 3 of them, this one leaks.
This was an easy repair. All I had to do was tighten down this packing nut. I then bled all the lines, yet again.
I have a plan for this, but I don't have the parts that I need yet, so I'm still using this janky glow plug setup. And I'm just gonna watch the amperage just to make sure everything's good there. Let's start it, let's warm it up, and just about ready to take this thing for a ride.
I can't get that to smooth out.
So you might be able to hear the engine is kind of sputtering right now, almost like it's missing occasionally, and as I work on this pump, that goes away.
Nice. Okay, turned itself off. That was sweet. I'm going to start it up again, and then I'm going to engage the hydraulic pump and hopefully be able to lift this up off of these supports, undo the chains, take the supports out, and put it down. That's the idea.
So I'm lifting it up with hydraulics, but the system is full of air, and I just want to make sure it's going to be able to support it before I remove the chains. The chains aren't holding any weight, they're just there for safety, but once I take the chains off, then I need to take the supports out. The only thing that's going to have it is the hydraulic system. Don't really want it to come crashing down. But a few times back and forth, it seems to be able to support it just fine. So I lower it back onto the supports so that I can go up and take off the chains. Then I pick it up off of the supports and take the supports out.
I'm going to take it out for a ride. Now remember, I have not addressed the steering clutches, so I can only turn one way. Now if I'm going forward, that's right. If I'm going backward, that's left, kind of.
So at this point, I think it's worth taking a step back and seeing where we started. My goal with this was to do a partial rebuild and make it stop smoking. This is how it was.
It's like my shop's burning down.
And here we are now. In spite of everything old Dora's thrown at me, that's pretty gratifying. Now you can see it still smokes when I put it under load. That's when I'm either hitting the brakes, changing gears, or going up a hill. And that's expected in these old diesels. They are going to smoke when you're pushing them. I'm using an infrared thermometer to monitor the exhaust temperature. If your timing is too advanced, you can actually get too hot and ruin your engine. Since there's a question with my timing mark, I wanted to check and be sure, but my exhaust temperature never got over 1,000 degrees Fahrenheit, which is reasonable. You can see as I was driving around, I keep trying the left steering clutch, and it never does anything. It does load the engine when I do that, so it's hitting the brake, but somehow not stopping the track. Apparently Pandora has more work for me to do. Damn it, Dora!
Coolant. There's no surge tank on this thing. It just overflows. I'm actually not sure the radiator cap is working. I still haven't hooked up the pull to stop wire, but if I do it, it will turn off. So that's nice. Yeah, see, that's all coming out of the hose there. I actually don't think that's a problem. I just think the radiator cap is not sealing and holding the pressure in like it should.
No leak under here, which is where you'd see it with that hydraulic hose that we replaced.
No coolant coming out of that, so that's good. Well, warts and all, I have an engine oil leak. It's on the gasket between the sleeve deck and the block, and I did not take that apart, because if I took that apart, it would guaranteed leak if I tried to put it back together. And I was not going to buy a new, that part is $1,700. I may try an epoxy fix on that, but you know, it's not that bad. I think this thing might just leak a little bit of oil. It's an old machine, they all do. There you go, guys. I'm done playing with Pandora for a while. Obviously, more work needs to be done on this machine. Honestly, I haven't decided what I'm going to do. I have other things that I need to work on, and this is definitely lower down on the list. I never expected this project to turn into what it did, but I'm really glad I did it. I've never rebuilt a diesel engine before, and even though that was a partial rebuild, I learned a lot of really valuable lessons, and I hope you learned something too. Certainly had a lot of fun, and a good test of my patience in fixing all the little things that go wrong, and there's even more of them. So that's another big lesson I learned on working on stuff that's really old and kind of beyond its service lifespan. You are going to have problem after problem after problem. My D3 dozer is old, but it's pretty functional, and you know, it needed some hydraulic work, and other than that, it was pretty usable. This is another story. Anyway, don't forget to hit that like button, subscribe, share with your friends. That's always appreciated, really helps out the channel. And thanks for watching. We'll see you on the next one.